Hello guys, today we'll be doing integral from the UNSW 2022 integration B knockout round. So yeah, this one's an improper integral, meaning it has infinity as one of the bounds. So in situations like this, you would usually try to do a sub of u equals 1 on x, because this will actually give you an integral with the same bounds being 0 and infinity. So then you can perhaps add it together to simplify the integrand a lot. So let's try this. So x equals 1 on u, let's differentiate. So differentiating both sides, we'll get this times du on dx. So dx will be equal to negative 1 on u squared du. Right, so we know when x approaches infinity, u would approach 0, and when x approaches 0, u would approach infinity. So I equals 0 to infinity. Oopsies, negative 1 on u squared du. One on u to 2022 times 1 plus 1 on u squared. Okay, so since it's a negative, we can absorb it and reverse the bounds. And then it will become something like this. Times u squared plus 1 on u squared. Okay, so now this u squared and this one will cancel out. So then the integral just becomes du u squared to 2022 plus 1, u squared plus 1 on u to 2022, which equals this. Okay, so we know an integral in this form will be equal to this by the fundamental law of calculus, where the capital F of u will be the primitive of f of u. So if you just consider changing the u to an x, well, what you're going to find is that you actually get the same answer. So for a definite integral, you can just change the u to the x, and the actual integral will remain the same. The actual answer will remain the same. So here, let's change this to, let's just change the u to x, so it will become dx on x to 2022 plus 1 times x squared plus 1. Okay, so let's add now this one and this one. So we know they're both equal to I, right, which is the value of the original integral here. So if we add them together, we get 2I equal to infinity to 0 of 1 plus x to 2022 dx on x to 2022 plus 1 times x squared plus 1. Cancel out, and then becomes this, which equals to arctan of x from infinity to 0, which just equals to this, and then minus 0. So obviously, arctan graph has a horizontal asymptote at y equals pi on 2. So this would be equal to pi on 2. Okay, it's a bit messy. So thus, if you just divide both sides by 2, y equals pi on 4. And we have our answer.